All right, well, I did a set of 4 puzzles, I don't know, a week or 2, 3 weeks, I don't know, not too long ago, that were an interesting rule set, and I'm going on to the next set of 4. There's, I think, 16 total in the pack that have been posted. These are by the Book Wyrm, and it's called the Octoquadri pack. The first puzzle in this set is called Radar. So we have our normal Octoquadri rules, which is true for all of these puzzles, that we're putting we're not doing normal Sudoku rules. We're not doing the digits 1 to 4 in each row and column and box. What we're doing is 8 of the digits from 1 to 9, so that no digit appears, twice in the same row or column or 2 by 2 box, but all of the 8 digits appear exactly twice in the whole grid. So we could put, for example, a 2 here and a 2 here, but we couldn't then put another 2 up here, right? It's exactly twice. So we have to have 2 of each of the 8 digits, and of course 8 of the digits from 1 to 9, so one of them is not going to be in the grid at all. And that is the main rule that applies to all of these puzzles. And now this first one, Radar, also has German Whisper and Renban and region sums. So German Whispers are the green lines, and basically the adjacent digits along a green line differ by at least 5. So you could put a 1 there and a 7 there. That would be fine. Or an 8 or a 6. But you couldn't put a 1 and a 4 because those don't differ by at least 5. And that's true of every set of 2 digits along the green lines. Blue line, so it is a little tricky for me with blue and purple because I am colorblind, but I'm pretty confident this is the blue line here. And then the purple is the other line. So the blue line is a region sum line. So essentially the region borders, the box borders, split that line into segments. So you have this piece, you have this piece, and you have this piece. Let's go yellow and red and green, right? So we've split the blue line into 3 pieces. The yellow is the same sum as the red as the green. All 3 of those each individually have the same sum. And then the purple lines are Renban lines, which means that the digits on a purple line are a consecutive set, but not necessarily in order. So you could do 1, 3, 2, 5, 4, and that would be fine. But you couldn't do 1, 2, 3, 6, 4. And that is all we need to know for this first puzzle. My camera has so many problems. It drives me crazy. I need to get a new one. There we go. If you have it on auto exposure, it overexposes and my face is just white. But if you don't have it on auto exposure, then when the sun goes behind clouds, then the lighting changes. And anyways, moving on with this puzzle. So, I'm gonna link in the description if you would like to try these out yourself. I'm gonna reset the timer and give it a try now. And so we know these are gonna be, alternating high and low. That's something you can do with German Whispers. Is if you think about it, since it has to differ by at least 5, even if you go as small as possible and go 1, the next one is gonna be at least 6. So you're gonna alternate between 1, 2, 3, 4. And 6, 7, 8, 9. And you can't put a 5 on a German Whisper because there's nothing that's at least 5 different. So these 3 and, these 3, they're the same, like, high-lowness, which I guess tells us something about the region sum lines, maybe? Because we know that since there's a single digit here, it's at most 9, right? And this has to be a small and a big. We don't know which one is which, but it's a small and a big, and so does this. So that's at least 7, right? 1 and 6 would be the minimums you could do. This one can't be 6 because you have to have 1s on both sides, but you could do. But if you let's think about this. Can you do 1 and 6? Can you do 7? Well, the only way to do 7 is 1 and 6, right? This can't be 6. This would have to be the 6, and this would have to be the 1. But that means the red is low. So now, down here, you can't do 6 and 1 because it has to be 6 and 1. But with the 6, you'd have to have a 1 on both sides. And you can't do that. So you actually can't do 6. Could we do... I think we could do 8, though. Could we do 8? No, because you can't do 6 and 2. So you can do 1, 7, but now you've got the same problem because the only way to do 8 on a German Whisper is 1 and 7 because you can't do 6 and 2. Can't do 3, 5, obviously. And you'd have the same problem of 1, 7. So we can't do 8. So it has to be 9. We can't do 7 or 8. It has to be 9. This is a 9. And so this means that because of the Renban, these are 8, 7, 6, 5. Because we have a 9 on the Renban, so these have to be 8, 7, 6, and 5. Now, we need 9, and it could be 1, 8, it could be 2, 7. You can't do 3, 6, because they have to be at least 5 different since they're on the German Whisper. So, 1, 8, or 2, 7. And those are 5 different, and this is going to be 1, 8, or 2, 7 also. Now, it could be... and since we know there's a 7 and an 8 on the Renban, and we need to have exactly 2 copies of every digit that we put in the grid, these can't be the same. They can't both be 1, 8, and they can't both be 2, 7, because that would be 2 7s or 2 8s, and there's a 7. So this is 1, 7 or 2, 8, or it's 1, 8 or 2, 7, and this one is the other. So there's a 7 on one of them and an 8 on the other. There's a 7 and 8 in here. That is both the 7s and the 8s. We can't put a 7 or an 8 anywhere else. And this is on a German Whisper, so it can't be a 5, but also it's high, so this is going to be low. 1, 2, 3, or 4. It can't be 4 because you have to have a 9 on the other side if it's 4. Okay, so that's a low. So we've already used both of our 7s and 8s, which means we can't put a 9 on, well, we could put a 9 here because this could be 8. You could do, but you can't put a 9 on here. You can't put a 9 in here. Where can we put a 9? This is the only place we can put a 9, which means this is 8. This is not 8. These are not 8, but also this is not 1, 8. That's 2, 7, which means this one is the 1, 8. Very nice. Now, if this is 2, then this would have to be at least 7, but it can't be 7. So this would have to be 8. If this is 2, this would have to be 8. But we can't do that because we've already got 2 8s. And it can't be 9, it can't be 7. So this is low, this is high. That means this is 8 and 1, and this is, well, 6, 7, 8, or 9, but it can't be 8 or 9, clearly. Either 6 or 7. Oh, but we're using a 7 in here and a 7 here, so this is a 6. This is 1, 3, or 4, but because it's next to the 6, it has to be the 1. So we've got both of our 1s. We can't do a 1 here. This can't be 6 because this can't be 1, so this is 7 and 2. So we've used both of our 2s. We've got 2 1s, 2 2s, 2 7s, 2 8s, 2 9s. We need another 6. One of these is a 6. So that 6. So that we know which ones. That's 5. This is 6. So we need a 5, and then so one of these has to be a 5, and then the other one has to be the same digit as this. So the 5 has to be here, and then this has to be either 4 or 6 because it's connected, so it has to be 4. And see, the sun came out, and now my face is all bright again. There we go. All right. Well, not too bad. 5, 10 on that one. Very interesting. All right, next up is called Courtyard, and again, we have the normal Octoquadri rule. We also have these killer cages, so digits in these cages sum to the number in the corner. So these 3 digits sum to 9, these 3 digits sum to 9, etc. This one doesn't have a total given, so it's just sort of to complete the pattern, I guess. The purple lines are Renban again, so we have a set of consecutive digits. Now, the different shades of purple are just to show that they're 2 different lines, right? So this is a line, this is a line, this is a line. They're all Renban lines, though. And then we have an inequality here, which just, it's just like the greater than sign. So this digit is bigger than this digit is all that's saying. So there we go. All right. Link in the description like usual. I'm going to reset the timer. And, well, 9, I mean, you can do 2, 3, 4, of course. But I think this is similar. Didn't we have something kind of like this on the other one where we had 3, I think it was a region sum thing instead of killer cages. But we had 3 sets of 9. And so they can't, none of them can be the same as what it works out to. Because if you did 2, 3, 4 twice, right? If both of these were 2, 3, 4, for example, it doesn't matter which 2, but 2 of them are 2, 3, 4. That would be all of your 2s, 3s, and 4s. So this minimum this could be would be 1, 5, 6, which is 12. So that doesn't work. So we can't do 2 of 2, 3, 4. But you also can't do 2 of, well, I mean, you can only have 2 of them with a 1, of course. So one of them has to be 2, 3, 4. The other 2 are going to have a 1. But if you did 1, 2, 6 twice, then your minimum for the other one is 3, 4, 5. If you do 1, 3, 5 twice, then your minimum is 2, 4. It just doesn't work. So you have to do one of them is 2, 3, 4. One is 1, 2, 6. And one is 1, 3, 5. Which uses both of our 1s, both of our 2s, both of our 3s. So we can't do any more 1s, 2s, or 3s. And 6 is interesting because if you put a 6 on any of these Renban lines, you know, the ends of the Renban lines are all in the cages, right? Well, but these cage down here, it's not the same because this cage isn't going to be limited. Well, so I'm thinking of this one, I guess. If you put a 6 in there, it would have to be 6 and 4 and a 5, which would work. Okay, but these are... So we've got all of our 1s, 2s, and 3s. So these are at least 4, 5, 6 as a minimum. So these two are minimum 4 and 5. Wherever the 5 is, the other side is at least 3. And on the 4, it's at least 2. So we can't put 1s in these. But you could go anywhere from 2 to 6. Well, can you though? Because let's say you put a 4 here. This could be 2 theoretically, but this would have to be 3. But we've used all of our 1s, 2s, and 3s in here, so you can't actually go down to 2. You can only go down to 3. It would have to be 3, 4, 5, or 3, 4, 5 like that, potentially. So you could do a 3. And we know there's a 5 and a 6. We definitely have 1, 2, 3, 4, 5, 6 in the grid. And the biggest these can be, wow, they could be 8, couldn't they? It could be 8, because this can be bigger. This is the minimum is 4, 5, 6, but these could be bigger. So, but it can't be 9. These two can't be 9. This one could be 9. But if this was 9, where would you put a 9? You can't put it on one of the Renbans. And this has to be smaller. So you actually can't. 9 is going to be the digit that we don't have in the grid. So we need 7 and 8. 8 can only go on one Renban. It can't go on this one. Because you'd have 6 and 5 as the maximum you could do on the others. You can put an 8 on one of these two. In fact, you're going to have to. So this can't be an 8 because you'd have to have a 9 over here because it would be bigger, right? So this can't be an 8. You can put an 8 in here. The other one has to be on one of these Renbans, which goes with the 6 in the cage and the 7 down here. So I think, and then you have the same problem with 7. 7 can be in the cage, but it can't be on any of the Renbans. Right? Or can it? I think you can do 8 on one of them and 7 on the other. The 8 would be with a 6. You'd have like 6, 8, 7, for example, or 6, 8, 7. Ah, but, haha, yeah. So wherever you put the 8 on the Renban, it's going to have a 6 in the cage. 8, 6, which would force a 7 over here, which means if this is 8, this is 7, so this can't be. And if this is 8, this is 7, so this can't be. So the other one cannot be 7. So one of these is 8, the other one cannot be 7. So you put a 7 in the cage, the other 7 has to go there. So this has to be the 8 then, which makes this the 6. This is 1, 2. This has to be 7, and this has to be the 8. Okay, so there's our 8s and our 7s. The 6 can't go here, but the 6 can't be in any of the other cages, so this has to be 6, which then means this has to be 4 and 5, I think. And so this is either 2, 3, 4 or 1, 3, 5. Either way, there's a 3 up there. And these are, one of these is 5, one of them is 4. This one, if this is, and the 4 and the 5 are only in the 9 cages once. So whichever one this is has to be here, and this one has to be there. 4 and 5. So this is 1, 2, 3. Again, it's a 3 with a 1 or a 2. Whichever one is not up here. Ah, but now we can look across here. Look at this. So how do we, if this was 5, because of the Renban, we'd have to have a 4. It can't be. This has to be 4, 5. And the 4 is going to have 3 and 2. And so this can't be a 1. This is 2, 1. These are not 1. Therefore, that's 2, 3, 4, 5. This is not 2. 3, 1, 2, 3. There we go. Very nice. 3 in the corner. Yep, we partied for the 3 in the corner. Cool. All right, the next puzzle is called Slanted. And again, we have our normal Octoquadri rules. And this one has a Renban, just like we've done before. This is consecutive digits in some order. We have a thermometer, which means the digits increase moving from the bulb to the tip. They don't have to be consecutive. You could do 1, 5, 8, 9, for example. Let's see. Then we have the cages. We have killer cages again. So these 4 sum to 13. These 4 sum to 13. We have white dot. The white dot separates digits that are consecutive. The black dot separates digits that are a 1 to 2 ratio. So you could do like 2, 4, 3, 6, something like that. And we have our inequality signs again. These are not V's for XV. If you're used to XV, these are inequality signs. So we have almost all the possible constraints in one little grid. Not almost all, but a lot of constraints in one grid. Link in the description. I'm gonna reset the timer. We'll see how this goes. Okay, so I want to say these are V's, but they're not. They're inequalities. So 13 and 4. Well, the minimum in 4 is 10, right? So 1, 2, 3, 4 is 10. So they've got to be pretty small. You can do 1, 2, 3, 7, or 1, 2, 4, 6. Is that the only options? Or 1? There's got to be a way to use a 5. 5 would leave 8, so you'd have 1, 3, 4, 5. Yeah, 1, 3, 4, 5 would work. So the biggest you can do is 7. But we know we're using 8 of the 9 digits, so there has to be 8 or 9 at least, if not both. And you can't put an 8 or a 9 in here, or in any of the cages, either of the cages, I should say. So, and you could only put one of them over here. I mean, you could put an 8 and a 9, but you can only have one copy over here. So there has to be an 8 or a 9 on the Renban, is what that comes down to, because you can't put an 8 or a 9 on any of these, and you could only put at most one copy of an 8 or a 9 on here, and the other one would have to be on the Renban. So therefore, these are a minimum of 5, 6, 7, 8. They're either 5, 6, 7, 8 or 6, 7, 8, 9. Those are the only options. This one has to be bigger than that one, so we can do that. And so, therefore, we at least have an 8, so there has to be an 8 up here, because you can't put 2 of them on the Renban. They have to be unique digits, and you can't put an 8 anywhere else. It has to be an 8 up here. You could do 8, 9, but this is not an 8. And with the black dot, this can't be 5, 7, or 9. So this is 6. Very nice. I like that. Nice. That was limited to a 6 by all the different possible things there, which means this is no longer an 8. This has to be an 8, which means we do not have 9s in the grid. So this is 5, 6, 7, 8. This is 5 or 7. And then this is a maximum of 6 because of the 7, but it can't be 6, so it could be 5. It's a maximum of 5. So it's 2, 3, 4, 5. This is 1, 2, 3, 4. So we have a 3. So this is now 10, which could be 1, 2, 7 or 1, 4, 5. I don't think you can do it without a 1. 1, 2, 7 or 1, 4, 5. This one can't be the 1 because it has to be bigger than that. This one can't be the 7. Can it be a 5? I don't think so because it's 1, 2, 7 or 1, 4, 5. So if you have the 5, then you can't put a 7 in here. So this cannot be a 5, but it could be a 4 because you could do 4, 5. And 7, 8. So we definitely have a 5, 7, and 8. The other 8 is up here. One of the 5 or 7 is here. The other one has to be in one of the cages. If it's a 7, then it's with 1, 2, 3. But you can do a 5 with 1, 1, 3, 4. And the other one then, okay, well that's interesting because we have a 5 or a 7 actually in this cage right here, don't we? This is 1, 4, 5 or 1, 2, 7. So there's a 5 and a 7 here. One of them is there. The other one is up here. We can't put a 5 or a 7 in here. So 1, 2, 1, and you can't put an 8 or a 9. So it's got to be from 1, 2, 3. Actually, we have to have a 6. Where are we going to put a 6? Look, we have a 6. We got to have another 6. There has to be a 6 in this cage. 6 with 1, 2, 4. So this is 1, 2, 4, 6. This is not 6. This is not 1. We have 1, 2, 4. This is not 6 either, actually. So actually, this can't be 4. 1, 2, 4, and 6. One of these is a 6. Okay. And this can't be 3. So where's the other 3? It can't be in this cage. It can't be on the Ren band. It can't be in this cage. Can't be there, here. This is a 3. So this is now 4 or 5. So we have a 1 and a 2 in both of these. Which means this is 1, 2, 7, not 1, 4, 5. Because if we do 1, 4, 5, we only have one place to put a 2 in this cage. So this has to be 1, 2, 7. There we go. And 1, 2, 7, 1, 2, 4, 6. This is bigger than that. This is 4. So 4. There's a 4 in here. The other 4 has to be there. 2, 1, 6, 4, 5. This is not 5. Therefore, this is 5. And now one of these is a 7. So either way, that can't be a 7. 1, 7, 8, 7. Very nice. Okay, cool. There was a lot of different constraints, but they actually worked well together. It wasn't like you use this constraint here and then you use that constraint. Like, they fit together really well. In fact, we used, like, I think almost all of them to get that 6, except for maybe the inequalities. So, very cool. All right, and the final puzzle in this pack is called Feeling a Little Purple. We have our normal Octoquadri rules, of course. We have the Ren bands again. The purple lines are consecutive digits in some order. And then we have little killers. So the numbers outside the grid give you the sum of the digits along the indicated diagonal. So like these 3 sum to 15, these 2 sum to 5, these 3 sum to 9, etc. And you can repeat digits on little killers as long as, you know, normal Sudoku and things. Well, this isn't Sudoku, but, you know, we can't repeat it in a box or a row or a column. So these two couldn't be the same, but these two could, basically. And that's all we need to know. So link in the description. I'm resetting the timer. Here we go. So, I mean, clearly the 5, it's 1, 4 or 2, 3, but because of the Ren band, it has to be 2, 3. Now this one could be 1, 4 or 2, 3. If it was 2, 3, that would be both of the 2s and the 3s. Which, but see, the 9, it's not quite the same because we can repeat digits. So you could do like 1, 1, 7 or something. Or 4, 4, 1, because you can repeat. So it's not necessarily a problem to do the double 2s and 3s. The 15. So the maximum we can put in here is 7, right? 4 and 3. So this has to be at least 8. So this is 8 or 9, which means this Ren band is 5, 6, 7, 8, 9. So it's either 5, 6, 7, 8 or 6, 7, 8, 9. Those are our two options. So there's definitely a 6, 7, and 8. And where are we going to put... So we have 4 high digits here. Where are we going to put all those? Because this, we could put one in here, maybe. Maybe. If you had low ones, like we said, 117 was possible. So we could put one in here. I guess you could maybe put two of them in the 12. You could do like 5, 6, 1. That's the only way you could put two high digits in there. And so you could put one here. You could put one in the corner and one in that corner. And then two. So there's 5 spots you can put high digits at most. And we've got 4 high digits. I'm saying high as in greater than 4 at this point. Max, we can... Oh, so those 4 plus 5, right? These two, 1 on the 9, 2 on the 12, is the maximum spots we can put high digits, which is 9. So we can't have 5 high digits. So we can't do 5, 6, 7, 8, and 9, which is fine. We need to do 4. But we need at least 4 spots that aren't on this Ren band. 1 on the 9, 1 here, potentially 2 on the 12. That's only 3. So we're going to have to use this corner. Both corners, in fact, are going to have to be high digits, which just means greater than 4. But I think this one also has to be high. I mean, it's at least 4, right? Like, this can't be very low. And this one, let's look at this for a second. So we've already got 2 and 3. So this is, if it's not 1, it's a minimum of 4, which then forces these to be low. And now you have to have, that makes it really tricky. It's doable. This would be, you'd have to have 5, 6, 1. If this is 4, it would have to be either 2, 3 or 1, 4 on the other sides. It would be the opposite of what this one is. I think that works. If this is 1, you're still doing, you could do 1, 1, 7. This would have to be 2, 3. So then you'd have both the 2s and 3s, both of the 1s. You'd have a 4. No, this would have to be 2, 3. Right. So you wouldn't have 4. But if you have both 1s and both 2s and 3s, this is a minimum of, what, 4, 4, and 5? Which is already too big. So that doesn't work. So you can't do, is that right? If this was, you can't do 1, 1, 7, is what I'm saying. So if this is 1, it's got to be 1 plus 2, 6, something. Three, 5, something. So, or 4, 4. I guess you could do 1, 4, 4 maybe. But then you can't. This would have to be 2, 3. So again, you've got 2, 3, and 4 gone. You could do 1, 5, and 6 then maybe. So this would be low. We could put 1 high on here and 1 low. The numbers don't work out very well. You've got, because we've already got 2 lows. This is low. That's 5. We need at least 1 more low. It's got to be an even number, right? Because every digit is in there twice. So 1 more is on the 9. If we put a high on the 9. And then we've got 1 more, but it can't be here. It's got to be one of these 2. But that's only 7. So where does the other one go? Are you putting 2 lows on the 12? Maybe? That could work, potentially. But they'd have to be on the outsides, I think. Can this be a low? Is the only way it can be a low is if it's a 4. Is that possible? I don't think it is. It would have to be 4 and 5. I feel like this... Part of me feels like it has to be a 1. Part of me feels like it has to be a 4. The problem is if this is low, if this is a 4, right? Now you've got 8, which means you're running out of places to put high digits is the problem. I don't think this can be low. I think this has to be a high one as well. So we've got 3 highs. We can put 1 on either of these. This is 1. We can't do 7, 1. So if this is 1, we would have to have a 2, 3, or a 4. Double 4s? 2, 3, 2, 3. But if you take away 2, 3, and 4, yeah. Oh! Right. I said, okay, so here's the thing. If you do 1, 4, 4, these are 2 and 3, and you can still do 1, 5, 6 on the 12. But look, a 1 here removes the chance of a 1 anywhere. Because even if this could be low, it can only be 4. It can't be 1, 2, or 3. A 1 here can't be in either of those. And you can't put it in here. Where are you going to put a 1? It's got to be on here. So then you've got 1, 1, 4. And you've got to put a 4 on here then. If this is 4, 1, 4, you can't put a 4 on the 12 then, because you've got the 2s and 3s. 4, 6, 2, maybe? Maybe you can. Oh, this can't be 1 or 2, by the way. Because it has to go with, so that, I don't know if that helps, but it's true. So if it's 4, 1, it's like that, but this is 1, then it removes 1 from the 12. And the only way you can put 2 highs on the 12 is if it's 5, 6, 1. I don't think this can be 1. I think this has to be a 4. Maybe I'm wrong, but I think it has to be a 4, which means this is 1, 4, or 2, 3 to be 5. It's the opposite of what these are. If this is 1, 4, then we've used both our 4s. This is 2, 3, 2, 3. In which case you'd have a 1 left over to go on the 12. If this is 2, 3, you've used up all your 2, 3s. This is 1, 4, and you have a 1 left over. So we have a 1 to go on here. We need 11, so 1, 5, I think this is 1, 5, 6. This can't be the 1. I think that's what it's got to be. This is 5, 6, or 7. There's definitely a 6 on here. Now, if this is 3, then they're both 3. Because you need 9, 3 to make 15 if this is 3. If this is 4... then these are 2 3s. So, what am I missing? These are 1, 4, 3, 2. Or these are 2, 3. Oh, well, one thing that we know is we have to have a 5, because this is 1, 5, 6. So now we can't have a 9. We can't have a 9. That's what we got to see. This is an 8. So these actually aren't 8 either. They are 5, 6, or 7. There's no 9 because we've already got 1, 2, 3, 4, 5, 6, 7, and 8 forced into the grid. There's no 9. So this is an 8, which means these have to be 7. So it's 4 and 3. And 2, this is not 2 or 4, and the 1 is gone. This is 3, this is 2, this is 1, So this is not 1, which makes this 1. And now one of these is a 6, so either one rules out that. So 5, 6. Oh, nope, nope, hold on. One of these is a 6, so this has to be 5, which makes this a 6. And so this is a 7 then. Okay. 5, this is 7. I don't know. Maybe I had some bad logic there. This has to be the 8, and this has to be the other 5. Oh, wow. Okay. I don't know. I feel like I convinced myself that this was a 4, but I'm not sure how thorough I was about it. So I don't know. Let me know if you did it a different way. And of course, let me know if you tried all 4 of these puzzles, how they went for you, and which one you thought was the best and the worst and the hardest and the easiest. And let me know if you'd like to see me try the 3rd pack in these. And of course, be sure to subscribe for more.